Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about Nbo analysis. You know my friends, full form of Nbo is natural bond orbitals. Nbo is a calculated bonding orbital with maximum electron density. Hierarchical atomic or molecular orbitals in the Nbo analysis like AO, NAO, NHO, NBO, NLMO, and MO. Starting from atomic orbital to molecular orbital, we have many steps like natural atomic orbitals, natural hybrid orbitals, natural bonding orbitals, and natural localized molecular orbitals. My friend, natural atomic orbitals are the optimal and maximum occupancy effective atomic orbitals in the molecular environment derived by diagonalize the localized block of full density matrix of a given molecule, which is associated with basis functions on that atom. You all know that. Then they meet simultaneous requirements of orthonormality and maximum occupancy. For isolated atoms, NaO coincide with NOs, natural atomic orbitals. For a polyatomic molecule, the natural atomic orbitals mostly retain one center character, in contrast to NOs that become delocalized over all nuclear center. So list the atoms with their respective natural atomic orbital type attached, angular momentum type, orbital type, and orbital occupancy. Population inversion, warning, or occupancy ordering inconsistent with energy order may occur for Rydberg type orbital of very low occupancy or near degeneracy in occupancy or energy, so that no significant physical effect are indicated. You can see this in your calculations. So gives natural atomic charges or sometimes attribute as NBO charges. The total core or valence and Rydberg populations on each atom. Atomic charges are the difference between the nuclear charge and the total neutral for neutral molecule electronic populations. So you will get in the calculations, you will get such type of windows, and there are a lot of values here. Now friends, in view output, natural electron configuration. Given as natural electron configuration for each atom can be somewhat related, idealized to the Lewis electron configurations. So, Rydberg bond index or NAO basis. This is also a part of NBO output. Bond order, originally a quantitative net measure of electronic populations occupying bonding molecule orbitals. So, Rydberg BI in natural atomic orbital basis. The original BI was defined for closed shell semi-empirical wave functions with the orthonormal basis, you can see WAB is equal to summations mu epsilon A, and we are using this formula overall. So here D mu V is the off diagonal density matrix. Element with NaO is an orthonormal orders. You know, for the general ab initio analysis, for which orthonormal basis sets is not used, this is Meyer's bond index. Again, further you can see over lap matrix, you can calculate here with the help of this formula. Nowadays, one may instead use some orthogonalized technique. Occupancy weighted symmetric orthogonalization is used, the Nbo analysis. For a spin polarized system, Nbo analysis is automatically performed 3 times, yielding 3 different parts of the outputs: total spin orbitals, alpha spin orbitals, beta spin orbitals, and the spin correlated bond order is the NAO basis will be, you have to follow this formula. So you have to do nothing, just you are getting from the already software developed on this topic, you will get such type of informations. So search for an optimum Lewis structure. Check whether reasonable Lewis structure is obtained. The occupancy of Lewis orbitals should not be lower than 1.90, and this is very important. And non-Lewis orbitals, anti-bonding or Rydberg type, should not be higher than 0.10. So occupancies, bond type, atomic and bonding center and their respective natural hybrid orbitals, compositions, that is covalent or ionic character. So the NHSU part lists the orbital hybridizations given in percentage and also in relative scale with lowest percentage orbital set as 1. For bonding in anti-bonding type orbitals, contribution of the NHs and polarization coefficient are also given. Below each NHO level is the set of NaO coefficient ordered according to the NaO's natural bond orbitals. The top of the part of the output, the carbon atom thus will have a set of 9 coefficient if calculated using a double zeta basis set. So summary of the angular properties of the NHSO. The directions of the hybrid is specified in terms of the polar theta and azimuthal phi angles. In a polar coordinate system, theta is equal to 90 degree, means orbital are on the xy plane, and phi is equal to 0.0, means orbital are on the x-axis. So summary of the second order perturbative estimates of the donor acceptor bonding antibonding interactions in the NBO basis, means second order perturbation analysis of Fock matrix. So the purpose of this analysis, what is the purpose we have to understand, is to give estimates of delocalization corrections with respect to the zeroth order natural Lewis structure, and that is the charge transfer characteristic. These perturbations lead to donation of electrons occupancy from the localized NBO of the de-idealized Lewis structure into the empty non-Lewis orbitals, and thus to departs from the idealized Lewis structure descriptions. So you can follow for the second order perturbation analysis of Fock matrix equation 4, where E2 refer to the 2 electron stabilization energy, and also you see the MO PMO theory models concept class. QI is the donor orbital occupancy, EI are the NBO orbital energies, and Fij is the off diagonal element of the NBO Fock matrix. All possible interactions are considered. Default threshold for the printing is 0.50 kilocalorie per mole. So, NBO summary, the qualitative delocalization to non-Lewis orbitals, the acceptor natural bond orbitals correspond to the principal delocalization test of the natural localized molecular orbitals associated with the parent donor NBO. So, localized molecular orbital, you can see NBO, you can see NLMO, you can see MO, molecular orbitals. So, NLMO summary tables or plotting will require NLMO keywords in the NBO input file. You can see NBO donor acceptor, NLMO, HOMO, and LUMO. So NBO orbitals are sorted by the type BD, CR, RY star, and BD star, NBO3. NBO orbitals are sorted by the type CR, BD, BD star, and RY, NBO06. NBO program will restoring these orbitals based on their occupancies from lower to higher, which will go in this order: CR, BD, BD star, RY star, RY, NBO06. The numbering in the molecular view, Gauss view, and Avogadro's are thus not referring to the numbering used by the NBO program. So you can see here window values. So 0Z09 input file, you have this basis set population NBO. Output input file, read from the check file, P method, basis set, geom, all check, gaze, read only, pop, NBOs, 6 read, save NBOs. And at the end of the file you can see mean frame, modules loaded Gauss, and modules load NBO. So NBO SUM requests printing of the NBO summary table. Reason requests search for the highly delocalized structure. No bonds requires that no bond to center NBO are to be formed in the NBO procedure, and this is useful for highly ionic species. 3C bond requests search for 3 center bond, and this is useful for diborane and other electron deficient bridge species. NLMO compute and prints out the summary tables of natural localized molecular orbital, and BNDIDX calculates the print Weber bond indices. NRT calculates prints natural resources theory analysis and bond indices. And E2PERT is equal to N. Increase or decrease the printing threshold for the second order perturbation stabilization energy. So you can see input file can be found in. So a lot of ammonia, you have changed 1 hydrogen with the fluorine, 2 hydrogen with the fluorine. Now you have the 3 fluorine only, no hydrogens. The same way you have carbon double bond nitrogen F, you have nitrogen nitrogen F, nitrogen nitrogen double F with the double bond. So how does different fluorinating affect the charge distribution in NF bond order? How does different substituents affect the charge delocalizations? Which orbital might be involved in this? What are the characteristics of the bonds? Can there be more than one possible or resonance structure? Bonus, sum up the total 2pz outer plane perpendicular to with respect to the molecular plane orbital occupancy. So my friends, you can see the values, you can see the picture here, mesh. So we have such type of data table you will get from the scientific publications. So my friends, I hope this video will be helpful to you. If you like this video,